So thank you again for inviting me to come speak, to impart what little knowledge I have on this subject to anybody that hopefully you can get something out of it. So the presentation is about scientific writing. I'm going to be talking about four main topics, some initial thoughts about the process, like how to organize yourself, and then a bit about the structure. Now, when I'm talking about scientific writing, I mean like scientific writing for journal publications. I have one book to my name, but I don't think I'm expert enough at that to say much about it. We'll see after the next one comes out. But for scientific papers, I have, I think I just crossed 100 of them earlier this year. So I'll talk about how I structure my papers and how I encourage my graduate students to structure their papers so that so they can be as amazing as I am at writing. And then I'm going to talk about how to organize your prose. That's probably the meat of it. And then at the end, just some smaller details that hopefully help in tightening up your prose. One thing that I think is fairly easy to say with some certitude is that a lot of scientific writing is really boring to read. And this will hopefully help in that regard when it comes to your writing. I think the most important thing when writing anything is to know what your audience is and who your audience is and what their background is, what they're interested in, why they're reading your paper. And then the second thing, I guess a commandment like unto the first, is to know what your message is. So know what it is that you're trying to say. And this usually comes down to thinking about what it is you're going to say before you start writing something down. So if you don't know who you're speaking to and you don't know what you're trying to say, then you're going to sound like some of the papers that are out in the literature right now. In particular, the scope of your paper. Oh yeah, how about if I advance the actual, here we go, here's my outline. So here's the outline, that's what I said. Fortunately, it was pretty short, so it's easy to read. Know your audience and know your message. And here, so the scope of your paper, self-control is essential to preventing the scope of your paper from creeping. I recently refereed a 40-page paper, and I was not happy with the fact that it was 40 pages. If it takes 40 pages to write a paper, either you're presenting multiple petabytes of data to the world, or you don't know how to curtail your I don't know, you don't have the self-control essential that I think is essential to this. A 40-page paper, while I recognize that there are certain circumstances where that might be necessary, this was not one of them. So one of the ways to, as you're developing your paper and you're working, I mean, especially if you're writing simultaneous to doing the research, which is kind of how I work as well, you want to know when to put the boundaries on what that paper is going to be about, and when to fork something into a different paper, into a different project. So at some point you might have a tangential finding that becomes more interesting than the original paper, and that's where your judgment comes in, to not turn it into a 40-page paper where 39 of those pages are not necessary. My philosophy, which is not shared by everybody, but that's okay, not everybody has to be right. My philosophy is that each paper should have one central message. If someone's going to read a paper of yours, they need to know what it is that they're getting out of it. So in choosing the message, here is an example. Most of these examples are what not to do. So these are two of my papers, or I'm sorry, this is one of my papers that should have been two of my papers had I followed my advice after I learned the lesson the hard way. So this original paper was 17 pages long. It had two primary results. One of them was the period ratio distribution of planets in exoplanetary systems, so like planetary systems orbiting different stars. And the reason we would care about the period ratio distribution is because that gives you some idea of the dynamical history of the system. So you can understand the history of the solar system by looking at the orbital periods of the bodies within the solar system, like Neptune and Pluto, for example. So we wanted to see, do exoplanetary systems have some of the same behavior that the solar system had in their history? So that's the figure on the left is Oh, this figure on the left. I'll do this for real next time. Even further up? Okay. No problem. Okay, I can say this. I can repeat what I said. So the figure on the left is the period ratio distribution that was seen in the Kepler data. We're getting positive feedback.
We're getting feedback.
Okay.
There was, but the mic appears to be off now. No sound still. No sound for a moment, but on. Can you make sure they
This is on. And the battery is 14 hours.
Yeah.
Are they getting sound off of this mic?
So that mic is for the recording, and then you see like these white things in the ceiling.
Uh-huh.
That is for the online folks, and then the lapel mic, hopefully with the speaker, it'll catch that, but hopefully that will be clear. But if not, I'll troubleshoot.
Okay, I'll keep talking and then you can interrupt me when the time is appropriate. Okay, good. So the figure on the left is the period ratio distribution of multi-planet systems seen in the Kepler data, and it was important for reasons that are contained in the paper. Excuse me. The figure on the right, nobody knows about, even though it's in the same paper. And this one looks at specific distances between the planets and certain mean motion resonances, like certain important configurations. And I think that this result on the right was at least comparable in importance to the result on the left, but nobody knows about it because I failed to exercise self-control and fork the paper into two separate results. And as a consequence, I think there's some stuff in this paper that hasn't really seen the light of day, even though it's out in the literature, but nobody reads that far because it's 17 pages long. So choose your message carefully and curate what it is you're trying to say in your paper. If you need to write 2 papers, it's not a bad thing to have 2 papers on your CV. Another thing that's important is not to ignore interesting results. So I was writing this paper on the left, and I mentioned that I was looking at these 2 histograms, and I noticed that there was stuff in one of the histograms that didn't show up in the other histogram, and I thought, oh, that's kind of interesting. I should probably look at this further. And then, rather than trying to package everything together into one single paper, I just took that and developed a second paper on the side. This one on the right, which is a consequence of the one on the left. Okay, this is not advancing. Okay, all right, so I will. Okay, so the figure on the left, these 2 histograms, and we have this gap here that's opened up where it shows up in one histogram but not in the other. The figure on the right is the paper that came as a consequence of seeing the feature on the left, but I didn't have time to explore in that one paper, so it developed into its own paper. Okay, so this is an example of me exercising proper self-control and encapsulating what I was going to say in the first paper and what I was going to say in the second paper. Maybe in the past this wasn't necessarily the way to do things, but there's a lot of important results in physics that are like 2-page papers. The discovery of the cosmic microwave background radiation, for example, is one that was basically a page and a half long, something like that. So, okay, next slide. So here's an example of a failure of mine where I had an interesting result and I did not follow up with a subsequent paper. So on the figure that's shown here, you see this blob it's a multi-dimensional kernel density estimator of the distribution of planets that in planet size on the vertical axis and orbital period on the horizontal axis. The important thing is not so much what the axes represent, but rather the fact that this blob has 2 peaks. Okay, I tried for about a week to measure the statistical significance of those 2 peaks, and I had written sentences in the text that I was submitting to the journal, and then I took it out. And what I should have done is kept it in and said, I'm going to follow up on this. What I did was I took it out, and then about a year later, the paper came out on the right. So next slide. Paper came out on the right. I mean, these are friends of mine, so I don't begrudge them their success. But this paper is one of the most highly cited papers in my field. 900 citations is a lot in my field. I mean, the only papers that get 900 citations are ones that everybody knows about. And so even though it showed up in my data and I had it there and I knew that it was interesting, I failed to at least stake some claim on it. And like in my own discipline, I'm famous enough. I don't necessarily need to have another paper with a lot of citations to it. But imagine had they not followed up on it, because I mean, 900 citations, there's a lot of research that's going into explaining why there's these two peaks in the distribution. And for probably a decade, that was a major emphasis in my discipline to kind of explain what was going on there. So had they not done their job, I didn't do my job, and we would know that much less about these systems. Okay, next slide. Next important thing to know about your message is that your research article is not a memoir. It's not a chronology of how you discovered things. You need to, after you finished your research, you need to take a look at what it is you're doing and decide what's the best way to present my research results, not my personal history. So the historical timeline of your work probably doesn't matter and may actually get in the way of understanding what's going on. Next slide. I think later on, if it's not next, then yeah, in a couple slides, I'll have an example of how, like what that looks like to have a chronology and what it looks like to fix the chronology. But I'll give you an example here. This was a paper that was written, I don't know, a while ago. David Rice is now a postdoc, but he was writing this originally as an undergraduate student, so it's been a while. And we were ready to submit. We've been working on it for about 4 years. Undergraduates often takes a while for them to learn what they're doing and get everything situated. So we've been working on it for about 4 years, and after that 4 years, this figure was sent to me in an email by David. He's like, look what I just found. This is kind of interesting, isn't it? And as soon as I saw this paper, I was like, this is the result. This is the most interesting thing that we've seen in 4 years, even though it was at the tail of the whole research project. And the whole paper, we rewrote the whole paper around this figure, because rather than writing it around all the work that we had done in the 4 years leading up to that point, it was essential work, but it led us to this point. And so the paper became more geared towards explaining what was going on in this figure. So the alternative would have been that we spend a lot of time talking about unimportant stuff, and then this gets missed because of a lack of self-control, or like, I went through all this pain, and so now you have to feel my pain. And that's not the way that research should work. If it's painful enough to read a lot of scientific writing, and so why make it worse by injecting your own personal story into it when the people really just want to understand what is this figure and what does it mean to me. All right, next slide. So when I structure my paper, almost all of my papers are structured in this same way. There's the abstract, introduction, a data or methods section, like where did I get my results, or what code am I using, and what kind of analysis am I going to do. And then I have the results. So once I have the data and I've told everyone what I'm going to do with those data, or once I have the simulation set up and what I'm going to do with those simulations, then I present the results. And then I have a discussion that connects my results to the literature and says, okay, so here was what we discussed in the introduction, and now I have these results, and here's the holes that it fills, and here's the things that are still left unanswered. And if I were to do it again, I would add, if I was going to improve upon it, I would do it in the following ways. That's a way, maybe for better or worse, that's a way to get citations, is to tell other people, here's what you can do with my work to advance the discipline further. I made this approximation, and the next time I do it, I would not use that approximation. Or if you want to cite my paper and follow up on it, then these are the ways that you can These are the holes that still remain that can be filled with someone's work. And then the conclusion is where you reiterate the important points that you discovered. And conclusions are generally, it's a relatively short section. I think the most interesting section for me is usually the discussion section, and then but the conclusion, it's not that it's unimportant. That's your opportunity to tell everyone, if you only take away 3 things from this literature exploration that you've just done, these are the things that you should remember. And then the appendix is for all the boring stuff that only 2 people in the world are going to care about. All right, next slide. Now, this is not the order that I write my papers. Can we go to the next one? I'm sorry. Yeah, go back. Okay, so what's in this paper? What's the gap in our knowledge? Why should somebody read this paper? When I talk to my graduate students, I'm always telling them, you need to know why, you need to tell the person why they're reading your paper. You need to front load all of your paragraphs, all of your sentences, so that they know it's important for me to reach the end of this sentence and understand what I'm reading. What did we do? What did we find out? What are the implications and limitations of our work? If you only remember a few things, remember these. And then at the end, like I said, the technical details that there's only a few people that are going to care about. And that's the other research group that's also using similar code, and they're going to, I forgot this Legendre polynomial in my analysis, and so something like that. Okay, next slide. The order that I write things is usually I do the data and methods first, and then I do my results and analysis. So okay, here's what I'm doing, and here's the code that I'm using, because that's pretty easy to write. And then I do the results and analysis, because now I have some figures that I can explain. And then I'll do the discussion, because that's what I find most interesting. And then I'll try to find a co-author to write the introduction, because that's what I find the least interesting. And then when all said and done, I'll do the conclusion. All the while, I try to, if there is an appendix, not every paper has an appendix, but if there is stuff that goes in the appendix, I just kind of pull it out as I'm going and stick it in the appendix. And then I write the abstract last, because I don't necessarily know what I've said. And honestly, the way that I write, I don't necessarily know all of the detail. Like, I haven't fleshed out the importance of what I've been working on until the end. And so you don't want to have a concise summary of what the paper's about until you actually know what the paper's about, which is part of the writing process. So anyways, the section order and the writing order are 2 different things. For me, you can write your paper any way you want. You can start with the appendix and work backwards if you want. The important thing is to know what the structure of your paper is going to look like and why those sections are there. Oftentimes you'll go to conferences and you'll have people that they'll sit there and talk about, they'll do a review that everybody in the room already knows about. They've already spent a third of their time talking about the same thing that the last speaker talked about. And then at the very end of their talk, when they have the opportunity to deliver some points that you should take away from it, they don't have any time left, and so they just say, well, I'll just put my conclusions on there and answer questions, which means you can't read their conclusions. Well, you have a choice. You can either read their conclusions or you can listen to the questions that are being asked, but not both, because they wasted their time doing unimportant things at the beginning. And so sitting down, understanding the reason the introduction is here is to motivate why I did this study, why this study is important, and also to tell the reader how your study is going to fit in with everything. The reason that the data and methods are there is so that someone can reproduce it if they wanted to. They know what code to use, they know what data to get, they know what cuts to make, they know what how long to expect things to run, they know what approximations you've made. The reason that you have the conclusion section is so all of these sections have a purpose for being there. And in your discipline, you may have other things that are important to be in there, like how you navigated the challenges of the internal review board or something like that. Anyway, so whatever discipline you're in, you might have extra sections, because not everybody can be as cool as physics or astronomy in the way that they present things. All right, next slide. Okay, the one after that. Okay, now turning from the structure of your paper to the actual prose that you're writing. My philosophy that I've gained over the last probably half a dozen years, is that the paragraph is the fundamental unit of your paper. So you have one paragraph, that's an opportunity to convey one idea that goes into it. Okay, next slide. Let's see, I would go 3 more slides. Yeah, there we go. Okay, unless it's impossible, you want to keep your paragraph short and focused. There's nothing, maybe it's because well, maybe I'm giving away some of my own internal flaws, but if I'm refereeing a paper where there's one column is one paragraph, I'm like, I have to read through this whole thing. So I try to keep my paragraphs short and focused on one idea. When I write a paragraph, I provide the motivation for why this paragraph is important as early as possible in the paragraph. Now, you want to have nice prose, but you don't want to have the point at the bottom of the paragraph. You want to front load it so the person reading it knows, oh, here's what I'm going to get out of this paragraph. I'm supposed to learn about the Brown 2000 whatever, and then you can read, then they know why they're reading the rest of the sentence. Because otherwise, if they don't know why they're reading the paragraph, then they're going to start thinking about something else, and they may miss something that is very important to you because it wasn't important enough to you to motivate upfront why they're reading it. So what I said here, your paper is not a murder mystery, so it's not a memoir, it's not a murder mystery either. You don't want to like, oh, and this clue showed up here. You want to just like tell people upfront, here's what you're getting out of this. So it is true that some historical missteps can be useful in the literature, but you want to be careful about where you place them because clarity is more important than chronology. Okay, next slide. So here is an example of, I didn't want to incriminate my former student. So we selected stars from Groovy Catalog using funky criteria. We refined our sample with tubular methods. Then we analyzed the sample with cool math. Because of esoteric physics, this approach didn't work. So we tried radical criteria and did a hipster analysis. That didn't work either. So we finally selected a sample from gnarly catalog using bodacious criteria. A Mondo analysis of that sample is shown in figure 2. Okay, in other words, we failed and we failed and we failed and we failed and we failed, and then the person reading it is going to be like, why am I reading this paragraph? The important stuff is what you actually did and what the results are from that. We selected a sample from this catalog using this criteria, and we did an analysis of it that shows up in figure 2. That's the important part of the paragraph. Why is it at the end that you have to read 6 sentences to get to the point? So if I had this, I would write it, next slide. Yeah, okay, that's the one, I'm sorry. Yep. We selected a sample of stars from gnarly catalog using bodacious criteria. A Mondo analysis of that sample is shown in figure 2. Then, if you want to tell them your sob story, or you want to tell yourself that your sob story is important so that someone else doesn't repeat the same mistakes, or not necessarily the same mistakes, but that someone else doesn't go down the wrong road and waste their time doing something that you know doesn't work. Then you put in, originally we tried to do these other things and they didn't work. But now your results are out, and if they're interested, they can read the next paragraph, and it's organized in a way where the reader knows, oh, now he's going to tell me, he or she is going to tell me what they did before that didn't work, and so do I care? If I care, then I read it, and if I don't care, then I skip to the next paragraph. It's kind of like reading a Robert Jordan book. It's like talking about divided riding skirts again and riding on the horse with a green dress. I'm not interested in this paragraph. I'm going to skip to the end of the chapter and see what happens with the main character. So same thing with your writing, because your scientific writing is a reference literature. It's not novels. Okay, next slide. Okay, and the one after that. All right, unless otherwise indicated. So let's see, it goes down to follow these rules. Yeah, there we go. I encourage, I dictate to my graduate students to use first person. We did this, I use we. That's why another reason why I always get a co-author is because they can write the introduction, and then then I can use we, and I don't have to feel weird about it. So we did the following things. Like, we did this analysis, we used this code, we got these data using active voice. So your verbs should be words that do things and not passive voice. And I'll show some examples about where the difference is. It's important to have a consistent tense as you're writing. So for me, I use the present tense when it's like, we analyze these data and the following stuff. That frees me up to use past tense in certain circumstances where maybe there's something in the analysis that we did a side quest to find out, some kind of debugging in the code or something like that. We found a bug and it's important for us to resolve in the literature because it shows up as a mistake in some other paper. Then I can use past tense to discuss that kind of thing and separate the prose into what's immediately important and then some other things that may crop up. Some people use past tense all the time. That's up to you, but I think this approach with using present tense for what I'm presenting frees me up to have to separate the tense and it basically just makes it more comprehensible, even if the reader doesn't know that that's what you're doing. So the next thing that I tell everyone is to use caveman grammar. We analyze data, as opposed to like the data were analyzed, just like subject, verb, object. If you don't speak like Yoda, you don't write like Yoda. Yoda's sometimes hard to understand, and it's hard for him to get to the point because his grammar takes too many words. And then I also say that it's very rare that adverbs are useful. Most adverbs don't mean anything unless it has a specific technical definition. They just don't mean anything. It basically means you don't know what you're supposed to say here, and so you're trying to make it sound important by putting a bunch of words in there that don't mean anything. They sound important, but they don't really mean anything. And I don't use adjectives all that often either. It doesn't mean that I don't have adverbs in my text. It does mean that any adverb that I use has either slipped through without me noticing it, or I needed to sound more important than it actually was, and I didn't have a better way to do it, and so I fell back on this crutch. But in general, your adverbs are not helping. So the advice that I give to my students is follow the rules first, and then you'll know when you can break them. But if you break them all the time, then you don't know why the rule, and you don't necessarily know why the rules are there, then you are limiting your own capacity to deliver your message effectively. So once these rules are down and you understand why they're there, then you can understand when it makes sense to break them in order to have better clarity in your text. Okay, next slide. Okay, just one slide, go back. Okay, so one more. Yeah. All right. Let's see, is that, yeah. Okay. Using a Brown 2000 oscilloscope, the voltage was measured with very high precision. This sounds like something you would read in a technical journal. Using a Brown 2000 oscilloscope, the voltage was measured with very high precision. This sentence says nothing. Okay, next slide with all the circles. Okay, so the least important information is up front because only 10 people are going to care about what oscilloscope you used. What they are going to care about is so the voltage magically was measured with very high precision, which doesn't mean anything. And so there's nothing here. Okay, next slide.